Hello everyone. Today, we're pleased to be presenting our remote automated off-grid greenhouse system. Our system is designed to automate climate and irrigation control, monitoring soil moisture, soil temperature, air humidity, and air temperature in order to ensure optimal conditions for plant growth. Whether it's for a small-scale farm or for commercial use, our system is scalable and adaptable to suit any agricultural needs, regardless of location or climate.
Our team is excited to demonstrate this small-scale proof of concept for our design, which is capable of monitoring multiple plots. This system has been designed using solar panels to provide electricity, making it completely off-grid, and has been created such that with an increased budget, it may be upscaled to suit the needs of full-scale greenhouses, such as the one at the Pie Farms in Labrador.
This is the current small-scale design of our greenhouse, which houses 3 plant plots as seen here. This, of course, can be scaled up with the implementation of more sensors. All of our circuitry is housed inside a 3D printed box, which can be seen right here. As well, the water supply for irrigation is stored inside the greenhouse. Our power is generated through a solar panel, which provides power to our battery via a charge controller. This is used to power our Arduino, a Raspberry Pi, all of our environmental sensors which are located inside the plots. And it also powers our pumps for irrigation, heating pads for temperature regulation of the soil, and a fan for ventilation.
These heating pads will turn on or off depending on the soil temperature. So if the soil temperature falls below 5 degrees Celsius, these heating pads will turn on. As well, for exhaust fan, this exhaust fan will turn on if the temperature within the greenhouse goes above 29 degrees Celsius to be able to cool down the greenhouse. And then lastly, we also have our irrigation pumps, which will turn on to water the plants if the soil moisture falls below 40%. So now we'll actually change some of these parameters to see the fan working and the irrigation system working in action.
So we changed the soil moisture parameter so that if the soil is less than 60% moist, the pump would turn on to water the plant, as we can see here. It turns off once it's over 60% moist as well. We also changed the parameter for the fan, so if it's over 19 degrees Celsius within the greenhouse, the fan will turn on, as we can see working here.
Now let's move on to a quick demo of the web app for the greenhouse automation system. The search page is the first page you'll see when entering the web app. The search page contains a drop-down menu where users can select which plot they wish to view. For this demo, we'll select plot 1 for later. There is a Go to Selected Plot button next to the drop-down menu, and when the user clicks on this button, the page will be redirected to the selected plant page. Underneath this button, there is a picture that provides a view of the inside of the greenhouse. Underneath this picture, there is a button that will bring the user to a camera view page that shows a larger picture of the inside of the greenhouse. On the left side of the page, 2 values are shown, the air temperature and humidity within the greenhouse. Underneath these values is a button that allows a user to switch between the air temperature and humidity graphs displayed on the search page. Underneath this button, we can see that the graph is interactive. We can also see that the button works in switching between air humidity and air temperature. Now let's take a look at the plant page. Here we can see the page for plant 1, which was selected earlier in the drop-down menu. On the left side is the soil temperature of the plant, and next to that is the soil moisture of the plant. After that is the time that it was last watered. Finally, on the right is the date the plant was planted. Underneath these values are the See Data buttons. These buttons take the user to graphs for the specific data. Here we can see a large interactive graph of the soil temperature of plant 1. The same type of graph is also available for soil moisture. You can also access the camera view page by clicking the camera icon present on the plant page. Here we can see the larger picture of the inside of the greenhouse on the camera view page. Finally, returning to the search page in the top left corner is a button that allows users to contact the developers through a Google form to aid in any required troubleshooting. This is a project that we believe can make a real difference by increasing greenhouse productivity, as well as assisting with food security issues if implemented in greenhouses throughout Labrador. Please contact us at the following email for any inquiries or questions about our product.